Hi folks, we're going to talk about the quantification of uncertainty and in particular the use of distributions for sampling in Monte Carlo simulation. Excel offers a variety of ways to sample from distributions, and of course that requires that you be able to quantify uncertainty before to identify the distributions that you'd like to use. Today I want to talk about two distributions, the first of which is the discrete distribution, and then secondly, we'll talk about the normal distribution. The discrete distribution is a discrete distribution that suggests that there are a countable number of outcomes that have corresponding probabilities of occurrence. So for example, I've created a probability distribution here where there is a 30% chance that the outcome 30 will occur, 25% chance that 50 will occur, etc. And of course, all these probabilities must sum to 1 to identify our distribution correctly. And so these are the only things that can happen. This is why we call it a discrete distribution. A very useful distribution, very simple, but don't let simplicity imply lack of sophistication. So how do we use the discrete distribution in Excel? Well, we're going to need a couple of tools. We're going to have to create a table and then do a lookup using a random number. The random number that we're going to generate is going to be through the use of the rand function. You can see it here, equal rand, and then open paren, close paren, nothing inside. And that returns a value between 0 and 1 that's uniformly distributed. We're going to take our probability distribution that we see here, once we've identified it, and then we're going to convert that into a cumulative probability distribution. The cumulative probability distribution always begins with 0, and then we start to add up the probabilities and accumulate them such that we wind up with, first of all, 0 here, 0.3 here. Why? Because this is probability 0.3, 0.55 here. Why? Because this is the sum of 0.3 and 0.25, and then 0.95, the sum of these three. We do not have to do the last probability, and you'll see why in just a second. So how do we generate samples from this cumulative distribution that represent this probability distribution that we've established here? Let's take a look at this formula here, the VLOOKUP formula. The VLOOKUP formula is going to take C14, which is this random number, 0.515012. It's going to go to this table. It's identified as, here's our lookup number. Here is our array where we have our table. And we're going to return the value in the second column, which is this column. So this particular function takes this value, it's changed now because it's recalculated itself, and is going to find it over here in this table. Now this number, 0.9315, etc., is not explicitly shown in this table, but you know that it lies between 0.55 and 0.95. The default in the VLOOKUP is that a value that goes between two values returns the value associated with a bracketed top value. We have a bracket here from 50 to 100. If we have a value anywhere between 0.30 all the way down to just barely below 0.55, it's going to return 50. And here I've collected 200 observations of these random numbers by doing this VLOOKUP in this table. And we can see that the results of that is that our distribution for outcomes here is actually slightly different from what we would expect. Here we get 36%, here we get 24%, here 37%. So not exactly what we saw here, but fairly close. Let me recalculate this table. Let me go to my formulas, recalculate it again, and see if we get numbers that are a little closer. This time they are 30%, 24, 41, and 6%. So Well, once we've generated these numbers, we want to create a frequency distribution. The frequency distribution is going to be created by, first of all, selecting bins. In this case, I'm going to select the outcomes because there are discrete number of values that are associated with the outcomes here. You don't see any numbers other than what you see here. And then I'm going to create a frequency function. The frequency function, as you know, let me erase this for a second to show you how we do this. Excuse me here. Let me erase it here. The frequency function is equals FREQ. Then it asks for the data array. The data array are going to be the values of our generated outcomes. Then it asks for the bins, and the bins I've selected here. I hit OK. Now I place my cursor here. I drag this area down here, not by the corner, but I drag this area here. An important step now, place your cursor here, flashing in the formula cell up above. Then simultaneously hit Control, Shift, and Enter, and see what happens is that we produce values in the cells that are equivalent to an array value. You can see these curly brackets here, and now this function has gone over here, counted all the number of 30s, 50s, etc. Let me recalculate this spreadsheet. You can see the numbers here now. Again, a bit of a difference in the values, 28% versus 30, 23% versus 25, 43% versus 40, and 7% versus 5. So this is how we create a discrete distribution, and we'll be using this in the creation of any number of simulations in the near future. That's the end of discrete distribution.